Hello everyone, my name is Abhinav and today I am going to explain the topic series. So by the end of this video, you are going to understand the definition of sequence and the definition of series. You are also going to understand the nature of the series, mainly converging series, diverging series and oscillatory series. So before we understand what a series is, let's understand what is a sequence. A mathematical sequence is a set of numbers written in a certain order, while a mathematical series is a sum of the terms in a sequence. So here we have 1, 3, 5, 7, 9, 11 is a sequence of odd numbers, whereas 1 plus 3 plus 5 plus and so on is a series of odd numbers. So a sequence can be changed into a series by simply changing the commas into addition signs. So you have a sequence, just replace the commas with the addition operation and you're going to convert it into a series. So let us look at another example. So here we have 1, 1 by 2, 1 by 3, 1 by 4 and so on. It is a sequence of the reciprocals of the natural numbers, but whereas 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5 and so on is a series of the reciprocals of the natural numbers. General term of a sequence. So every term in the sequence can be generated with the help of an expression which is denoted by Tn. Tn denotes the nth term in the sequence. So for example, consider the sequence 1, 1 by 4, 1 by 9, 1 by 25 and so on. So by observation we know that Tn is equal to n square. So if we plug in n equal to 1, T of 1 is 1. So the first term in the sequence is 1. If we plug in n equal to 2, we get T of 2 which is 1 by 4. So the second term in the sequence is 1 by 2. If we plug in n equal to 3, we get T of 3 which is 1 by 9, which is the third term in the sequence and so on. So coming to the nature of the series. Nature of the series is of three types: converging series, diverging series and oscillatory series. Let us understand each of them one by one. Converging series. Let Sn denote the nth partial sum of a sequence. So Sn is denoted by T1 plus T2 plus T3 so on up to Tn. We say the series is converging if we apply limit n tending to infinity on Sn, it results a finite value. So we find the value of Sn and we apply the limit of n tending to infinity. If we get a finite value, the series is said to be converging. So coming to diverging series. First we find the Sn, which is the nth partial sum, which is T1 plus T2 plus T3 so on till Tn, and we call this series diverging if we apply the limit of n tending to infinity to Sn and we get an infinite value, meaning Sn tends to either positive or negative infinity. So coming to oscillatory series, let Sn denote the nth partial sum of a sequence. So Sn is again T1 plus T2 plus T3 so on up to Tn. The series is said to be oscillating if we apply the limit n tending to infinity and the limit oscillates between two values. Now we're going to understand each of them with an example. So firstly, coming to converging series. So let us consider the sequence 1, 1 by 2, 1 by 4, 1 by 8. So the first and foremost step is always to write the general term of the sequence. The general term of the sequence is given by 1 by 2 power n. So let us convert the sequence into series. So we get the series as 1 plus 1 by 2 plus 1 by 4 plus 1 by 8, and let Sn denote the nth partial sum. So by observation we know that this is in a geometric progression. So to get the sum of infinite terms in a geometric progression, we need to know the first term and the common ratio. The first term here, which is denoted by A, is 1, and the common ratio, which is denoted by R, is 1 by 2. So the sum of infinite terms in a geometric progression is A divided by 1 minus R. So limit S of n tending to infinity is simply nothing but the sum of infinity in a geometric progression, which is A by 1 minus R, which is 1 by 1 minus 1 by 2, which results in 2. Since the value of the limit is a finite value, we say that the series is converging. So 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 converges to 2. Coming to diverging series. So here the first and foremost step is consider a sequence. So here we have the sequence 1, 3, 5, 7, 9, 11. So the next step is to write the general term of the sequence. The general term is given by T of n, which is 2 into n minus 1. So we convert the sequence into series by replacing the commas with the addition operation. So the series is 1 plus 3 plus 5 plus 7 and so on. So again, let Sn denote the nth partial sum. By observation, we know that the sequence represents the odd numbers. So the first So the sum of first n odd numbers is given by n into n or n square. So we apply the limit n tending to infinity s of n is equal to n into n. So where n tending to infinity, n tends to a very huge number, n into n also tends to a very huge number. So the limit tends to infinity. Since the value of limit is an infinite value, the given series is diverging. So the series diverges to infinity. So coming to an oscillatory series, so consider the sequence 2, minus 2, 2, minus 2, 2, minus 2 and so on. The general term of the sequence is given by t of n is equal to 2 into minus 1 power n. So consider the series. Consider the series 2 plus minus 2 plus minus 2 plus and so on. Let Sn denote the nth partial sum. Since the sequence contains positive and negative 2's that alternate, so the sum depends on the nature of n. So if n is odd, Sn is going to be 2. So here, so if we stop the sequence at here, the sum is 2. If we stop the sequence at here, so 2 plus minus 2 plus 2, it's going to be 2. And if we stop the sequence at at even places, it's going to be 0. So if we stop at here, if we stop the series here, we are going to get 2 plus minus 2, which is 0. And if we are going to stop here, it's going to get 2 plus minus 2 plus 2 plus minus 2 is 0. So if we apply the limit of n tending to infinity, the value depends on the nature of n, whether n is even or n is odd. If n is odd, the value of the limit is going to be 2, and if n is even, the value is going to be 0. Since the value of limit is oscillating between two values, between 0, it's either going to be 0 or it's either going to be 2. And how do you know that? It depends on the nature of n, whether n is positive, n is odd, or n is even. If n is odd, it's going to be 2, and if n is even, it's going to be 0. Since the value of the limit is oscillating, the given series is oscillatory. So that's it for now, guys. Thank you. If you have any doubts, please do leave it in the comment section. Thank you.